If I have an aldehyde like benzaldehyde, and I treat benzaldehyde with ammonia in the presence of acid, so in the presence of trace H3O+, the goal of my reaction would be to make an imine that looks like this. But the problem is that this imine is unstable. I can't make an imine where I have that nitrogen-hydrogen bond, so I'm not able to use ammonia as my amine in this process. So I can't form that product. So because I can't form that product, I do have a little bit of a workaround, and that is that I can take this aldehyde and I can treat this aldehyde in a one-pot, two-step reaction where I can treat it with ammonia and trace H3O+, which are the conditions that would allow me to make that imine, but that imine is unstable and I can't isolate it. But if I include in this reaction hydrogen gas and palladium on carbon, I can get a one-pot, two-step reaction where the product that I make out of this reaction is a primary amine. In the primary amine that I make out of this reaction, this carbon of the original aldehyde is this carbon of my primary amine. So this is a good reaction to make a primary amine, and under the conditions of this reaction, what's going to happen is that my benzaldehyde will first undergo a reaction with my ammonia and my acid, and what I'll make out of that reaction is this intermediate. While I can't isolate this intermediate will exist in my solution, and as this intermediate then comes into contact with my hydrogen gas and my palladium on carbon catalyst, I get a hydrogenation of this carbon-nitrogen double bond, and I end up with my primary amine as the product of this reaction. So again, it's a one-pot, two-step reaction. It's a great synthetic tool. So this is a specific reaction sequence that uses ammonia as the amine, but I have some other options as well. I could also take a ketone like this one and treat this ketone with a primary amine like this one in the presence of trace H3O+ and make an imine. This is a stable imine. This is one that I can isolate. And so now I can take this imine and I can treat this imine with a reducing agent. I can treat this imine with a specific reducing agent that is triacetoxy sodium borohydride, where I have 3 acetate groups bonded to my boron. My boron has 1 hydrogen. I have a sodium counter ion, so that this is going to be a source of H-. This is going to be a reducing agent. I'm going to follow this with a water workup. And the product that I get out of this reaction is this one. Where this is a secondary amine. I can also take a ketone like this one and treat it with a secondary amine, trace H3O+, so conditions that will allow me to form the following enamine. If I then treat this enamine with my reducing agent, so sodium triacetoxy borohydride, followed by a water workup, the product that I get out of this reaction is this one. So this reaction sequence allowed me to make a tertiary amine. So as an example of a synthesis question, we could look at a synthesis where I ask you to take this carboxylic acid and this aldehyde and combine them in order to make this tertiary amine. So when it comes to your strategy, you'll need to think about ways that you know how to make tertiary amines, and there's multiple syntheses that you could come up with. The limitation that you'll have on this reaction is that you may only introduce monofunctional compounds with one carbon or less to incorporate them into your final product. You also must use this carboxylic acid and aldehyde in your synthesis. Pause the video and come up with a synthesis. Again, there's more than one way that you could come up with a synthesis for this compound, so let me demonstrate one way that uses several of the reactions we've discussed. I could take this carboxylic acid and treat it with thionyl chloride and heat in order to make an acid chloride. With this acid chloride, I could react an amine. So I could bring in a 1-carbon amine, like this one, and I could make an amide out of that reaction. That gives me a secondary amide where my nitrogen has 2 carbon-containing groups bonded to it. One is a methyl, the other is a 2-carbon group that's currently part of my amide functional group. I could take this amide and I could do a reduction with lithium aluminum hydride, followed by a water workup, and that would give me this secondary amine as the product of the reaction. I could now use this secondary amine in a reaction with my 3-carbon aldehyde in order to make an enamine. So I could bring in my 3-carbon aldehyde, trace H3O+, and that's going to make my enamine. In the final step, I could do a reductive amination. So I could take this enamine and I could treat this enamine with sodium triacetoxyborohydride followed by a water workup, and the product that I would get out of that reaction is my tertiary amine.